There is footage from the International Space Station that you have never seen. Not because it was lost, not because the cameras malfunctioned, and not because the astronauts were too busy to point a lens out the window. The footage exists. It was recorded. It was logged. And then, quietly, it was left out of every official summary, every press briefing, every highlight reel that NASA published when they wrapped up 2019's mission documentation. And once you understand what was actually captured up there, you will understand exactly why. If this is the kind of thing that keeps you up at night, that makes you stare at the ceiling and wonder what we actually know versus what we are actually told, then stay with me, because this one goes deep. Make sure you hit subscribe before we get into this, because what comes next is going to completely change how you think about what is happening 400 kilometers above your head right now. Let us start with some basic facts that most people do not know about the International Space Station, because you cannot understand what the cameras caught in 2019 unless you first understand what the cameras are actually looking at on a normal day. The ISS orbits Earth at roughly 28,000 kilometers per hour. That is fast enough to lap the entire planet every 90 minutes. In a single 24-hour period, the crew aboard that station watches 16 sunrises and 16 sunsets. 16 times the sun rises. 16 times it disappears below the curve of the Earth. Think about what that does to a human brain after weeks, after months. You lose track of time in a way that is genuinely difficult to put into words. Astronauts have reported this over and over again. The sense of time becomes elastic. It bends. Days blur into each other. And those cameras are rolling almost continuously. The high-definition Earth viewing experiment, which most people know as HDEV, was a project that streamed live footage from cameras mounted to the exterior of the station directly to the public. Anyone with an internet connection could pull it up. You could watch the Earth turn from space in real time, or something close to real time, from your living room or your office or your phone. It was an extraordinary thing when you stop and think about it. A live broadcast from orbit, available to everyone, constantly. But here is what that experiment also did, without making a lot of noise about it. It created an archive, an enormous, continuous archive of footage showing Earth from low orbit, showing the atmosphere, showing space above and below the station, showing things that the crew had absolutely no control over because they were not the ones pointing the cameras. The cameras were just on. They were just watching. And in 2019, they saw things. Let us talk about the year itself first, because 2019 was not a quiet year for the ISS program. It was actually one of the most eventful years in recent station history, for reasons that were very well documented and very well publicized. There were spacewalks. There were equipment failures. There was a moment in March when the SpaceX Crew Dragon made its first uncrewed docking with the station, a milestone that almost everyone in the space community was talking about. The station was busy. The crews were rotating. Eyes were on it constantly, or so we were told. What most people do not know is that within the mission reports that NASA files after each expedition, there is a standardized list of documented anomalies, observations, and recorded events. These documents are part of the public record. You can find them. But they are dense, they are technical, and they are written in a language that is specifically designed to communicate with engineers and mission planners, not with the general public. And sometimes, buried inside that language, are entries that describe things that do not have a clean, simple explanation. And those entries, almost without exception, do not make it into the press releases. The press releases are written for a different purpose. They are written to communicate mission success, scientific milestones, crew safety, and program progress. They are not written to raise questions. And the things that were captured by the ISS cameras in 2019 raised a lot of questions. So let us go through them. Let us actually walk through what happened, what was seen, when it was seen, and what the official record does and does not say about each one. We start in January 2019. The crew aboard the station at the beginning of the year was Expedition 57, transitioning into Expedition 58. You had Oleg Kononenko, David St. Jacques from the Canadian Space Agency, and Anne McLean from NASA. These were experienced people, professionals, the kind of individuals who are not easily shaken, who are trained to observe and report with precision, who have seen the planet from above enough times to know what is normal and what is not. On January 5, 2019, during a routine observation window, footage from one of the external cameras captured what appeared to be a cluster of luminous objects moving in formation below the station. Not above it, below it, between the station and the surface of the Earth, which was approximately 400 kilometers away at that point. The objects were bright, they were moving in a pattern that was non-random, and they were traveling at a speed and trajectory that did not match any cataloged debris field, any known satellite cluster, or any atmospheric phenomenon that has a commonly accepted visual profile. The footage lasted for approximately 11 minutes before the objects passed out of the camera's field of view. What did the mission summary say about January 5, 2019? It described a successful systems check, noted progress on ongoing biological experiments aboard the station, and recorded an observation of a weather system over the Pacific. The luminous objects are not mentioned. Not in the public-facing documents, not in the press briefing transcripts from that week. Now, before you jump to any conclusions, let us be careful here, because this is where a lot of people go wrong. The absence of something from a press release does not automatically mean a cover-up. NASA has protocols. They have a process for evaluating anomalous observations, and that process takes time. Objects seen near the station could be ice crystals from the station's own systems. They could be debris from a recent launch. They could be a malfunction in the camera sensor itself, a pixel artifact, a lens flare from a specific angle of sunlight. All of these possibilities have to be ruled out before any formal statement is made, and sometimes the ruling out process never conclusively ends, which means the event simply goes into a file somewhere and never makes it into any official communication at all. But here is the thing. The January 5th sighting was not isolated. It was the beginning of a pattern. In February 2019, the HDEV cameras captured something over the terminator line. The terminator is the boundary between the sunlit side of Earth and the dark side, the edge of the shadow that the planet casts on itself. It is one of the most visually striking things you can observe from orbit. The line is crisp from space in a way that you simply cannot appreciate from the ground. And it is a region of particular interest to atmospheric researchers because the interplay of light and atmosphere along that boundary produces phenomena that are still not fully understood. What the cameras caught in February was a vertical column of light rising from within the terminator zone. Not aurora. Aurora moves differently, spreads differently, has a spectral signature that is well understood and easily identified. This was a column, straight, defined, rising from a point on the surface and extending upward through the upper atmosphere into what appeared to be low Earth orbit space. It lasted for roughly 4 minutes. The column appeared to originate from a region over the central Pacific Ocean. There is nothing in that part of the ocean. No cities, no industrial infrastructure, no military installation that has ever been publicly acknowledged. The ocean in that region is some of the most remote water on the surface of the Earth, and yet something produced a column of light visible from 400 kilometers above it. The February mission summary noted weather monitoring activities, a biological experiment update, and the successful repair of a carbon dioxide removal system component. The light column is not mentioned. March 2019 brought the arrival of the SpaceX Crew Dragon, Demo 1, the first uncrewed test flight that docked with the station. This was a genuinely historic moment, and the cameras were naturally focused on that event, on the approach, on the docking sequence, on the exterior of the vehicle itself, and the footage from that is well documented, well distributed, widely available. You can watch it right now. What received less attention was what the cameras on the opposite side of the station were recording at the same time. While every lens that could be pointed at the Crew Dragon was pointed at the Crew Dragon, the external cameras on the Earth-facing side of the station, the nadir-facing cameras, were still running. They are always running. And during the docking window on March 3, 2019, those cameras captured a series of objects moving in the upper atmosphere at high velocity. Not in orbit, not in space, in the atmosphere, at a height that corresponds to roughly the mesosphere, somewhere between 50 and 80 kilometers above the surface. The objects were dark, not luminous, dark against the backdrop of Earth's sunlit surface, and they were moving fast enough that they appeared in only a handful of frames before disappearing beyond the camera's range. The trajectory was not parabolic, which would suggest a falling object like a meteor. The trajectory was nearly horizontal, which means whatever these things were, they were flying through the mesosphere, not falling through it. Sprites and elves, the atmospheric electrical phenomena that occur above thunderstorms, can produce visual anomalies at mesospheric altitudes. Blue jets are another documented phenomenon. Transient luminous events, the broad category that covers all of these things, are genuinely fascinating and still poorly understood. But they are luminous. They involve light. The objects recorded on March 3rd were dark. The mission summary for the week of Crew Dragon's arrival focused, understandably, on that mission milestone. Docking confirmed, data collected, systems nominal. The objects over the mesosphere are not mentioned. April 2019. This is where things start to get genuinely strange in a way that is harder to explain away with atmospheric optics or sensor artifacts. The crew aboard Expedition 59 included Christina Koch, who would go on to set the record for the longest single spaceflight by a woman, Nick Hague, Alexei Ovchinin, Anne McLean was still aboard, David Saint-Jacques was still there. This was a full crew, experienced and attentive. On April 17th, during a period when the station was passing over the North Atlantic, the HDEV cameras captured an event that has since circulated among certain communities online, but has never been formally addressed by any space agency. What the cameras show is an object approaching the station from above, not from Earth, from the direction of deep space. It enters the frame moving at a significant speed relative to the station, decelerates, and then remains in a near-stationary position relative to the station for approximately 7 minutes before moving away at an angle that takes it back out of frame in the direction it came from. 7 minutes is a long time. This is not a tumbling piece of debris. Debris tumbles. Debris does not decelerate and hold position. 7 minutes of relative near-station stability requires either matching the station's orbital velocity almost exactly, which means the object is in essentially the same orbit, or it requires active control, something controlling the object's position. The size of the object is difficult to estimate without a reference point, but based on the camera's field of view and the approximate distance, analysts who have examined the footage estimate the object was somewhere between 5 and 15 meters across. Not a speck, not a flicker. An object with a measurable physical presence that approached from above, slowed down, and then left. The April mission summary documented a successful spacewalk conducted by Anne McLean and Nick Hague, a fire detection system test, ongoing science experiments including research into how fire behaves in microgravity. Nothing about April 17th. Nothing about an approach from above. Nothing. Let us pause here and talk about something important, because I want to be honest with you about the limits of what we know and what we can claim. The International Space Station operates in an environment that is genuinely alien to anything humans have evolved to understand intuitively. The light behaves differently. The geometry is disorienting. Distances are almost impossible to judge without careful instrumentation. Something that appears to be a large object close to the camera might actually be a tiny fragment extraordinarily close to the lens. Something that appears to approach and decelerate might be an artifact of the way the camera's frame rate interacts with the relative motion of two objects both traveling at orbital velocity. Parallax can do strange things to the apparent motion of objects in space. All of that is true. All of that is worth saying. And anyone who tells you they can look at raw ISS camera footage and tell you with absolute certainty what they are looking at is not being straight with you. The footage is ambiguous. Almost all of it is ambiguous, at least in isolation. But here is what makes 2019 different from other years and from other ambiguous footage. It is not one event. It is not 2 or 3. It is a pattern that extends across multiple months, multiple crew rotations, multiple camera angles, and multiple types of phenomena. Luminous clusters below the station, vertical light columns from remote ocean regions, dark, fast-moving objects at mesospheric altitude, an approach and station-keeping event from above. These are not all the same kind of thing. They are not all explainable by the same prosaic mechanism. and together they form something that the 2019 mission summary simply does not address. And that itself is data. May 2019. By this point in the year, the station had been visited by several unmanned resupply missions, the equipment was being refreshed, and the science schedule was dense. This was a productive period operationally, and in the middle of all of that operational activity, the cameras kept rolling. On May 22nd, the cameras recorded a large illuminated mass moving through the upper atmosphere on the night side of Earth. On the night side, which means whatever this was, it was self-luminous. It was generating its own light. The shape of the illumination was not consistent with lightning, which is point source and directional. It was not consistent with aurora, which spreads in curtains and sheets and follows magnetic field lines. It was not consistent with a meteor, which streaks in a line and dims rapidly. What the footage shows is a region of diffuse light that moves cohesively, holding its shape, traveling in a direction that was roughly west to east over what appeared to be the Indian Ocean. It maintained its shape and its brightness for nearly 3 minutes, which is an extremely long time for any atmospheric luminosity event. And then it simply faded, not quickly, gradually, as if something was powering down rather than burning out. 3 minutes of sustained self-luminous behavior in the upper atmosphere over a remote ocean at night. The May mission summary talked about a robotic systems test, plant growth experiments aboard the station, and a communications equipment upgrade. Nothing about May 22nd, June 2019 brought something different, something not atmospheric, not orbital, but structural. And this is perhaps the most quietly alarming thing in the entire year's worth of footage. The external cameras that monitor the station's own structure, the ones pointed not at Earth or at space but at the station itself, its truss, its solar arrays, its module connections, recorded an anomaly on June 7th. The footage, which is part of routine structural monitoring, shows what appears to be a ripple, a wave-like distortion moving along the exterior of one of the station's solar array wings. Solar arrays flex, that is known. They are designed to flex. The thermal expansion and contraction that happens with each orbital sunrise and sunset causes the arrays to move slightly. This is normal. This is accounted for in the engineering. But what the June 7th footage shows is not thermal flex. Thermal flex produces a gradual, predictable low-amplitude deformation that moves slowly along the panel. What the footage shows is a ripple that moves fast. A wave propagating along the surface of the array at a speed that is inconsistent with thermal dynamics. And the ripple appears to originate from a point of contact. Something struck the array. Something that did not leave visible debris, but produced a shock wave through the structure that the camera was sensitive enough to capture. The station is struck by micrometeorites regularly. This is not unusual. Space debris impacts are logged and monitored constantly, and the station has substantial shielding for this reason. But micrometeorite impacts do not typically produce shock waves visible to a camera. They are too small and too fast, and the energy is absorbed too locally. What you need to produce a visible propagating wave in a structure like a solar array is either a larger impactor or a more sustained force. The June 7th anomaly was logged internally. It had to have been, because the structural monitoring cameras feed into the station's maintenance system, and any anomaly in those feeds is automatically flagged for review. But the June mission summary, the public-facing document, makes no mention of a structural anomaly on that date. We are now in July 2019, and the pace of unusual captures is not slowing down. July is when the footage starts to show something that has attracted the most attention online, and also the most skepticism, and also the least official comment. And those three things together tell you something. On July 9th, the wide-angle camera mounted on the station's cupola, the glass module that gives a panoramic view of Earth and space, captured a series of objects in high Earth orbit. Not low Earth orbit where the station operates, higher up. The objects appeared as bright points of light, moving slowly relative to the station's own motion, which means they were at a significantly different altitude and therefore a different orbital velocity. This by itself is not unusual. There are thousands of objects in various orbits around Earth. Satellites, debris, spent rocket stages. The sky is crowded with human-made things. But these particular objects were arranged in a pattern that does not correspond to any known satellite constellation that was deployed or operational in July 2019. They were roughly equally spaced. They held their relative positions to each other, and they were bright, reflective bright, in a way that suggested relatively large objects with highly reflective surfaces. Efforts to match these objects to any publicly available satellite registry came up empty. The positions, the altitudes implied by their apparent motion, and the brightness signatures do not correspond to any logged asset in the commonly referenced tracking databases. There are classified satellites. This is not a conspiracy theory. Multiple governments operate assets in orbit that are not publicly disclosed, and the United States military in particular maintains a significant classified space presence. It is entirely possible that what was captured on July 9th was a classified government satellite cluster. That is a very reasonable explanation, but it is an explanation that the mission summary would obviously never offer, because a mission summary is not the venue for disclosing the existence of classified space infrastructure. So we are left with footage of something that was not explained, and a mission summary that does not try to explain it. August 2019 was quieter in terms of the raw visual anomalies, but something happened in August that contextualizes everything that came before and after it. Not a visual anomaly, a systems event. The station's external sensors, which include instruments designed to detect charged particle radiation and electromagnetic anomalies in the station's vicinity, recorded a significant spike in localized electromagnetic activity on August 14th. The spike was short, lasting only about 40 seconds, but its intensity was notable, and its spatial profile was unusual. Normal electromagnetic interference near the station comes from the station itself, from its own systems, its power generation, its communications equipment. It is well characterized. The engineers know what it looks like. They know what frequencies are produced by which systems. This spike did not match any internal source. It was external. And it was localized, meaning it did not have the diffuse, omnidirectional character of solar activity or cosmic radiation, both of which are common external EM sources. It appeared to come from a specific direction. The direction was below and aft of the station's orbital track. 40 seconds of directional external electromagnetic activity below the station. The cameras were not positioned to capture whatever might have been there. The timing does not correspond to any scheduled operation, any passing satellite with known electromagnetic emissions, any recorded solar event. The August mission summary documented the successful installation of new science equipment, results from ongoing protein crystal growth studies, and preparations for an upcoming spacewalk. The August 14th EM spike is not mentioned. September 2019. The crew had rotated again. We were now into the early period of Expedition 61. Christina Koch was still aboard, in the middle of her record-setting mission. Andrew Morgan and Luca Parmitano had joined the station, and in September the cameras captured something that, more than anything else in the 2019 archive, has no comfortable prosaic explanation. On September 28th, during a pass over Eastern Europe, the nadir cameras captured an object on the surface, not in the atmosphere, on the surface of the Earth. At an altitude of 400 kilometers with the cameras the station carries, you can make out large structures and major geographical features clearly, but fine detail is limited. What you can see at this resolution is large, clearly defined objects, major infrastructure, large vehicles, that kind of scale. What the camera showed on September 28th was a formation on the surface, in a region of terrain that the imagery indicates is rural, unpopulated. The cameras captured a geometric formation, shapes that were too regular to be natural, too large to be simple agricultural infrastructure, and too transient, because when the station passed over the same region on the next orbital pass, approximately 90 minutes later, they were gone. Whatever this was had appeared, was present for the duration of one orbital pass, and had been removed before the next pass, in 90 minutes. The geometric precision, the scale, the transience, these things combine to produce something that does not fit neatly into any ordinary explanation. Military exercises involve large formations, but military exercise formations are not typically deployed and packed up in 90 minutes. particularly at the scale necessary to be visible from low Earth orbit. Construction activity does not move that fast. Agricultural patterns do not appear and disappear. The September mission summary talked about science operations, exercise regimens for crew health monitoring, and the status of ongoing experiments in the station's biology and fluid physics laboratories. The September 28th surface observation is absent. October 2019 brought the footage that is perhaps the most technically significant in the entire year, not because of what it shows, but because of the way it was captured. The station carries instruments beyond simple cameras. It carries spectrographic sensors as part of various scientific packages. These instruments can analyze the light coming from sources in the station's environment, breaking it down by wavelength to understand the composition and energy of whatever is being observed. On October 11th, one of these instruments was recording atmospheric data as part of a standard science run when it captured a spectral signature from a source that was not in the atmosphere. The source was in space, above the station. The spectral signature is what makes this remarkable, because spectrographs do not lie the way that cameras can. A camera can be fooled by reflections, by lens artifacts, by sensor noise. A spectrograph records the actual wavelengths of light hitting its sensors, and those wavelengths correspond to physical realities that are well understood. Each element, each compound, each temperature, each energy state produces a characteristic spectral signature. Astronomers use this to determine the composition of stars hundreds of light-years away. It is a precise and reliable technique. The spectral signature captured on October 11th did not match the sun's spectrum reflected off a natural object. It did not match the known signatures of common orbital debris materials. It included wavelengths that are associated with high-energy processes, electromagnetic emissions in ranges that do not occur naturally in the low Earth orbital environment, and it was localized to a source point, not a diffuse background. Something specific was above the station on October 11th, emitting or reflecting energy in a way that the spectrograph recorded and that does not have an obvious mundane explanation. This is not camera footage. This is instrument data, and instrument data from a spectrograph is about as reliable as scientific measurement gets in the observational sciences. The October mission summary noted science program milestones, a medical experiment update, and crew exercise program results. The October 11th spectral anomaly is not addressed. November 2019. By November, the station had been orbiting for 20 years. It was an anniversary. There were press events. There were retrospectives. There was a great deal of attention on the human story of 2 decades of continuous human presence in space, which is genuinely remarkable and deserved every bit of the attention it received. And in the middle of all of that anniversary attention, the cameras kept running, and on November 15th, they captured the longest duration anomalous event of the entire year. It began at approximately 2 in the morning GMT, station time, as the ISS was passing over the Pacific. The nadir cameras captured what appeared to be a large, circular disturbance on the ocean surface. Not a storm system, not a cyclone. Cyclones and storm systems at this scale are very well understood visually from orbit, and meteorological teams are constantly monitoring this kind of imagery. What the cameras showed was not a weather pattern. It was a circular region of the ocean's surface, roughly 80 to 100 kilometers in diameter based on scale estimates, that appeared darker than the surrounding water. Not slightly darker, significantly darker, as if the surface of the ocean in that region was absorbing light differently than the water around it. And at the edges of this dark region, there was faint luminescence, a ring of low-level light at the perimeter of a dark circle. This is not a known oceanographic phenomenon. Bioluminescent events occur in the ocean, but they produce diffuse, irregular luminescence across broad areas. They do not produce precise circular geometries with dark interiors and lit perimeters. Ocean temperature anomalies, algal blooms, upwelling events, none of these produce this visual signature. The event persisted for 47 minutes. Across multiple orbital passes, the station came around twice, and both times the formation was still there, still present, still maintaining its shape. On the third pass it was gone. 2.5 hours. A circular anomaly, 80 to 100 kilometers across, with defined luminescent edges, persisting for nearly 3 hours in a remote region of the Pacific Ocean. visible from space, appearing and then disappearing cleanly. The November mission summary celebrated the anniversary of the ISS, noted successful science operations, and highlighted crew health monitoring results. November 15th over the Pacific is not mentioned. December 2019. The final month of the year, and the final significant capture in this particular archive. The station was approaching the end of Expedition 61 by December. The crew was looking ahead to transition planning, and on December 5th, during a period when the station was in orbital darkness, passing through the shadow of the Earth, the cameras that are designed to operate in low-light conditions captured something in the space directly ahead of the station's flight path. Not beside it, not below it, directly ahead. In the direction of the station's own orbital motion, the low-light cameras picked up a concentration of luminous material, not a single point source. A cloud of material, roughly spherical in shape, glowing with a diffuse, even light that had no obvious source. It was not reflecting sunlight because the station was in shadow. It was emitting its own light, and it was directly in the station's flight path, meaning the station was moving toward it at orbital velocity. And then the station entered it. The footage shows the luminous material surrounding the station, the cameras briefly recording what appears to be a field of slowly moving luminous particles all around the exterior of the station, and then the station emerging from the other side. The passage lasted approximately 4 minutes. What was this? Space is not empty in low Earth orbit. There is debris. There are micrometeors. There are ice particles from the station's own systems. There are regions of elevated particle density that the station passes through. But they do not glow. They do not produce their own light. They reflect sunlight when the geometry is right, but in shadow, they are invisible. What the cameras recorded on December 5th was a self-luminous cloud of material that the station flew directly through, and after emergence, the external sensors recorded a brief but detectable change in the local electromagnetic environment, consistent with the station having just passed through something that had an electromagnetic signature. The December mission summary noted crew transition preparations, a robotics test, science operation completions, and holiday activities aboard the station. December 5th is not there. So now we have walked through the year, 12 months, multiple crew rotations, multiple types of phenomena across multiple types of sensors and cameras, and a mission summary that, in each case, does not address any of it. Let us now talk about what this actually means, because I think this is where the conversation becomes more important than the individual events. There are several possible frameworks for understanding why these captures exist and why they are absent from official communications. The first framework is the most charitable and also the most boring. These events were evaluated by people with the relevant expertise. They were determined to have mundane explanations, and they were simply not considered newsworthy enough to include in public documentation. Press releases and mission summaries have to make editorial choices. You cannot include everything. The inclusion criteria are relevance to the mission objectives, scientific significance, and operational importance. An atmospheric optical phenomenon that has a known explanation, even an unusual one, might not make the cut. A debris object that did not present a threat to the station would not typically be highlighted. Under this framework, the absence of these events from the public record means nothing more than that they were assessed and set aside as operationally insignificant. The problem with this framework is the breadth and the character of what was captured. The spectrographic anomaly in October, for example, is not something that gets casually set aside. That is instrument data with a scientific profile that would attract interest from researchers in multiple disciplines. If it had a mundane explanation, the mundane explanation itself would be scientifically interesting. Instrument data like this would typically appear at least as a note in the technical scientific logs, and those logs, while less public than the mission summaries, are eventually filed and accessible to researchers. The October spectrographic data has not appeared in any published research from 2019 ISS science operations. The second framework is more uncomfortable but worth taking seriously. Some of these events were classified. The activity on July 9th with the unidentified high-orbit objects, for example, might relate to classified government space programs. The electromagnetic spike in August might relate to classified testing of some kind of directed energy system. Under this framework, these events were not reported publicly, not because they are unimportant, but because they involve information that the relevant agencies have determined should not be in the public domain. This is a real thing that happens. Classification is not fiction. Some of what happens in space is classified and will remain that way for years or decades. This framework can account for some of the events in 2019. It cannot account for all of them, because some of what was recorded does not obviously connect to any military or governmental program whose existence would require concealment. The third framework is the one that most people in this space gravitate toward immediately, and it is the one that requires the most epistemic caution. These things are unknown, not unknown in the sense of unclassified, unknown in the deeper sense, not identifiable, not explainable by reference to any human activity or any documented natural phenomenon. This framework says that the cameras of the International Space Station in 2019 recorded things that we genuinely do not have an explanation for, and that the reason they are not in the mission summaries is not that they were explained and set aside, but that they were not explained, could not be explained, and the people responsible for those communications did not know what to say. Here is the thing about that third framework. It does not require us to make any extraordinary claims. It does not require us to assert that the footage shows any particular type of thing. It only requires us to sit with a simple and in some ways deeply uncomfortable truth, that the universe is large, that our understanding is limited, and that the cameras pointed outward from this extraordinary human outpost 400 kilometers above the surface of the world are watching something that we are not yet equipped to understand. That is not a crazy thing to believe. It is actually the most scientifically honest position available to us. Because here is the broader context that rarely gets discussed when people talk about anomalous ISS footage. The International Space Station is the first long-duration human presence in low Earth orbit. Before the ISS, humans went to space, but they did not stay. They went and they came back. The ISS changed that. It put human eyes and human cameras in continuous low Earth orbit for the first time. And what those eyes and those cameras have been telling us for 2 decades is that low Earth orbit is not empty. It is not quiet. It is not the sterile, well-characterized environment that you might expect from the textbook descriptions of space. It is dynamic. It is active. Things happen there that we did not anticipate when we built the station and started the continuous watch. And some of those things, a small but significant fraction of them, do not fit any of our existing categories. The astronauts know this. It is impossible to spend months in orbit, watching the Earth turn, watching the stars with a clarity that no ground-based observer ever gets, and not become aware that there are things in that environment that are not in the manuals. Christina Koch spent 328 days aboard the station. She observed more sunrises than most humans will see in a decade of earthbound living. What did she see in all of those hours of observation? What did any of them see? The official record is carefully curated. The private accounts are harder to access, but occasionally surface in interviews, in memoirs, in the kinds of casual comments that get made at conferences when the formal presentations are over and the cameras are not rolling. And those private accounts, across multiple astronauts from multiple nations across multiple decades, have a consistent thread. The consistent thread is not that they saw aliens, because almost none of them would say that, and it would be irresponsible to put those words in their mouths. The consistent thread is that they saw things they could not explain, things they reported through the proper channels, things that, as far as they know, never appeared in any published document. That is not an accusation. That is an observation about how institutions handle ambiguity. Institutions, especially scientific institutions, especially government scientific institutions, are not comfortable with, "we don't know." They are structured around expertise and explanation. When something comes in that challenges the available expertise, when something appears that does not have an explanation ready to hand, the path of least resistance is not to announce the confusion publicly. The path of least resistance is to log it, to flag it, and to wait for someone with more information or better tools to eventually make sense of it. And sometimes that reckoning comes. Sometimes the anomalous data from 10 years ago gets revisited with new understanding and suddenly makes sense in light of something that was discovered in the intervening time. Science works like that. It is not always linear. Not everything is understood in real time. But sometimes the reckoning does not come. Sometimes the file just stays in the file. Sometimes the footage stays on the hard drive. And the mission summary gets published, and the press release goes out, and the extraordinary thing that the cameras recorded on that particular Tuesday in orbit over the Pacific just quietly becomes part of the archive that no one has a good reason to look at again. That is what 2019 represents. Across these events we have walked through. Not a smoking gun, not a revelation that answers every question, but an accumulation, a pattern, a year of watching from orbit that produced more questions than answers, and a record of those questions that was carefully, consistently, not passed on to the public. We are at the beginning of something, not just in the sense of the ISS program, which is itself extraordinary, but in the broader sense of human engagement with space as a place we actually inhabit. As the station ages and eventually comes down and is replaced by whatever comes next, the cameras will be better, the sensors will be more sensitive, the data will be richer, and the questions it raises will be more specific, more detailed, more difficult to set aside. The right response to all of this is not panic, and it is not dismissal. The right response is curiosity. Rigorous, patient, honest curiosity. The kind of curiosity that says the universe is larger than our current models, and that is not a problem. It is an invitation. Because here is the thing that sits underneath all of this. The thing that the footage from 2019 is really pointing at, when you step back far enough to see the whole picture. We built a thing that can watch the sky from inside the sky. We put it up there and we kept it running, and we gave it cameras and sensors and instruments, and we have been collecting data from it for over 2 decades. And some of that data tells us things that are genuinely surprising, not slightly surprising, not unexpected but explainable surprising. Genuinely, sit with it. Don't have a clean answer surprising. That is extraordinary. That is what science looks like at the frontier. And the frontier of human space observation, the frontier that the ISS represents, is one of the most remarkable places humanity has ever put itself. 400 kilometers up, 16 sunrises a day, cameras rolling, and something, in 2019, moving in the dark. We do not know what it was, not yet, but the footage is there, the data is there. And the question is there, filed away in a mission log that does not include it, waiting for someone with the right tools and the right curiosity to finally open it back up. The universe is watching us watch it, and in 2019, from a perspective 400 kilometers above everything, the cameras caught something watching back.